settle down, that you found a girl and you're married now. I heard that your dreams came true. Guess you gave you things I didn't give to you. Old friend, why are you so shy and like you to hold back or hide from the light? I hate to turn on out of the blue uninvited, but I couldn't stay away, I couldn't fight it. I hope you see my face and that you leave in mind, and that for me it isn't over. Never mind, I'll find someone like you. I wish nothing but the best for you too. Don't forget me, I beg. I remember you said sometimes it lasts in love, but sometimes it hurts instead. Sometimes it lasts in love, but sometimes it hurts inside. You know how time flies on me. Yesterday was the time of our lives. We were born in a race, and a summer haze, bound by the surprise of our glory days. I hate to turn on out of the blue uninvited, but I couldn't stay away, I couldn't fight it. I hope you see my face and that the things in mind, and that for me it isn't over. Never mind, I'll find someone like you. I wish nothing but the best for you too. Don't forget me, I beg. I remember you said sometimes it lasts in love, but sometimes hurts instead. Sometimes it lasts in love, but sometimes it hurts inside. Nothing compares, no worries or cares, regrets and mistakes. There are memories made. Who would I know how bittersweet this would taste? Never mind, I'll find someone like you. I wish nothing but the best for you too. Don't forget me, I beg. I remember you said sometimes it lasts in love, but sometimes hurts instead. Never mind, I'll find someone like you. I wish nothing but the best for you too. Don't forget me, I beg. I remember you said sometimes it lasts in love, but sometimes it hurts inside. Sometimes it lasts in love, but sometimes it hurts inside. It's okay, don't be alarmed, come into me. There's no distance in between our lives. So gonna let the rain pour, I'll be all you need and more. Because when the sun shines, we shine together. Told you I'll be forever. Said I'll always be your friend. Took it all, I'ma stick it out to the end. Now that it's raining more than ever, know that we still have each other. You can stand under my umbrella. You can stand under my umbrella. Ella, ella, eh, eh, eh. Under my umbrella. Ella, ella, eh, eh, eh. Under my umbrella. Ella, ella, eh, eh. Under my umbrella. Ella, ella, eh, eh, eh. It's raining. Oh, baby, it's raining. Baby, come into me. Come into me. It's raining. Oh, baby, it's raining. You can always come into me. Come into me.
This week, we're going to be talking about two seemingly different ideas, procrastination and memory. But the two topics are intimately related. Why? Because building solid chunks in long-term memory, chunks that are easily accessible by your short-term memory, takes time. It's not the kind of thing you want to be putting off until the last minute. You already have one good tool for procrastination, the Pomodoro, that powerful 25-minute concentrated period of energized focus. This week, we're going to fill you in with more information about how procrastination happens and simple ways to tackle it. And this is key, ways that don't take much willpower. Then we'll move on to talking about some of the best ways to access your brain's most powerful long-term memory systems. I'm Barbara Oakley. Thanks for learning how to learn. Arsenic is incredibly toxic. For centuries, until modern methods of detection were discovered, murderers found it to be a very popular substance. So you can imagine the shock at the 48th meeting of the German Association of Arts and Sciences in 1875, when two men sat in the front of the audience and downed more than double a deadly dose of arsenic. The next day, the men were back at the conference, smiling and healthy. How is it possible to take something so bad for you and stay alive, and even look healthy, despite the damage being done at a microscopic level to your body? The answer has an uncanny relationship to procrastination. That's what we're going to be talking about in the next few videos. You've already learned one handy tool to help you with procrastination, the Pomodoro, that 25-minute period of uninterrupted focus, followed by a bit of relaxation. This week, we're going to learn more. Understanding a little about the cognitive psychology of procrastination, just like understanding the chemistry of poison, can help us develop healthy preventatives. In these videos, I'm going to teach you the lazy person's approach to tackling procrastination. This means you'll be learning about your inner zombies, the routine, habitual responses your brain falls into as a result of specific cues. These zombie responses are often focused on making the here and now better. As you'll see, you can trick some of these zombies into helping you fend off procrastination when you need to. Not all procrastination is bad. Even if you're pretty good already in handling procrastination, you'll learn some helpful insights here that can allow you to better prioritize your learning. The reason that learning to avoid procrastination is so important is that good learning is a bit-by-bit activity. You want to avoid cramming, which doesn't build solid neural structures. By putting the same amount of time into your learning, but spacing that learning out by starting earlier, you'll learn better. First things first, unlike procrastination, which is easy to fall into, willpower is hard to come by. It uses a lot of neural resources. You shouldn't waste willpower on fending off procrastination except when absolutely necessary. Best of all, as you'll see, you don't need to. If you'll remember, we procrastinate about things that make us feel a little bit uncomfortable. You think about something you don't particularly like, and the pain centers of your brain light up. So you shift and narrow your focus of attention to something more enjoyable. This causes you to feel better, at least temporarily. But sadly, the long-term effects of habitual avoidance can be nasty. When you put off your studies, it can become even more painful to think about studying it. You can choke on tests because you haven't laid the firm neural foundations you need to feel comfortable with the material. Procrastination can be a single, monumentally important keystone bad habit. A habit, in other words, that influences many important areas of your life. If you improve your abilities in this area, many other positive changes will gradually begin to unfold. Procrastination shares features with addiction. It offers temporary excitement and relief from sometimes boring reality. It's easy to fool yourself, for example, into thinking that the best use of any given moment is surfing the web for information instead of actually reading the textbook or doing the assigned problems. You start to tell yourself stories. For example, you might tell yourself that organic chemistry requires spatial reasoning, your weakness, so of course you're doing very poorly at it. You devise irrational excuses that sound superficially reasonable, like, if I study too far ahead of the test, I'll forget the material. If you're troubled by procrastination, you may even start telling yourself that procrastination is an innate, unchangeable characteristic. After all, if procrastination were easily fixable, wouldn't you have fixed it by now? The higher you go in your studies, however, the more important it is to take control of procrastination. Habits that worked in earlier years can turn around and bite you. What I'll show you in these next few videos is how you can become the master of your habits. You should be making the decisions, not your well-meaning but unthinking zombies, your habits. As you'll see, the strategies for dealing with procrastination are simple. It's just that sometimes they aren't intuitively obvious. So let's return to that story that began this video. The arsenic eaters started with tiny doses of arsenic. In tiny doses, arsenic doesn't seem harmful. You can even build up an immunity to its effects. This can allow you to take larger doses and look healthy even as the poison is slowly increasing your risk of cancer and organs. In a similar way, procrastinators put off just that one little thing. They do it again and again, gradually growing used to it. They can even look healthy, but the long-term effects, not so good. I'm Barbara Oakley. Thanks for learning how to learn. Just imagine backing out of a driveway for the first time ever in your life. For some of you, that might seem like a pretty exciting proposition. The first time you might do this, you would be in hyper alert. The deluge of information coming at you would make the job seem almost impossibly difficult. But once you've chunked how to back up down your driveway, all you have to do is think, let's go, and off you go. Your brain goes into this sort of zombie mode where it is only semi-aware of a few key factors instead of being overwhelmed by all the data. It's the same idea with riding a bicycle. At first, it's really hard. Later, it's easy. Neuroscientifically speaking, chunking is related to habit. Habit is an energy saver for us. It allows us to free our mind for other types of activities. You go into this habitual zombie mode far more often than you might think. That's the point of habit. You don't have to think in a focused manner about what you're doing while you're performing the habit. It saves energy. Habits can be good and bad. They can be brief, like absolutely brushing back your hair, or they can be long. For example, when you take a walk or watch television for a few hours after you get home from work. You can think of habits as having 4 parts. The first is the cue. This is the trigger that launches you into zombie mode. The cue may be something as simple as seeing the first item in your to-do list, time to start next week's homework, or seeing a text message from a friend, time to stop work. A cue by itself is neither helpful nor harmful. It's the routine, what we do in reaction to that cue, that's what matters. Number 2, the routine. This is your zombie mode, the routine, habitual response your brain is used to falling into when it receives the cue. Zombie responses can be useful, harmless, or sometimes harmful. Number 3, the reward. Every habit develops and continues because it rewards us. It gives us an immediate little feeling of pleasure. Procrastination is an easy habit to develop because the reward, moving your mind's focus to something more pleasant, happens so quickly and easily. But good habits can also be rewarded. Finding ways to reward good study habits is important for escaping procrastination. Number 4, the belief. Habits have power because of your belief in them. For example, you might feel you'll never be able to change your habit of putting off your studies until late in the day. To change a habit, you'll need to change your underlying belief. I'm Barbara Oakley. Thanks for learning how to learn. One of the best ways of being effective in your learning is to use mental tools and tricks to inspire and motivate yourself. First, when it comes to learning in general, you should realize that it's perfectly normal to start with a few negative feelings about beginning a learning session, even when it's a subject you ordinarily like. It's how you handle those feelings that matters. Researchers have found that non-procrastinators put their negative thinking aside, saying things to themselves like, quit wasting time and just get on with it. Once you get going, you'll feel better about it. If you find yourself avoiding certain tasks because they make you feel uncomfortable, you should know there's another helpful way to reframe things, and that's to learn to focus on process, not product. Process means the flow of time and the habits and actions associated with that flow of time, as in, I'm going to spend 20 minutes working. Product is an outcome. For example, a homework assignment that you need to finish. To prevent procrastination, you want to avoid concentrating on product. Instead, your attention should be on building processes. Processes relate to simple habits, habits that coincidentally allow you to do the unpleasant tasks that need to be done. For example, let's say you don't like doing homework in a particular class, so you put off working on the homework. It's only 5 questions, you think. How hard could that be? Deep down, you realize that answering those 5 questions could be a very lengthy job. It's easier to live in a fantasy world where the 5 questions or the 10-page report or whatever can be done at the last minute. Your challenge here is to avoid focusing on the product, the answers to the questions. The product is what triggers the pain that causes you to procrastinate. Instead, you need to focus on the process or processes, the small chunks of time you need over days or even weeks to answer the questions or prepare for tests. Who cares whether you finish the homework or grasp the key concepts in any one session? The whole point instead is that you calmly put forth your best effort for a short period. The process. Notice how in this picture, physicist and surfer Garrett Lisi is focused on the moment, not on the accomplishment of having surfed that wave. For you, one of the easiest ways to focus on process is to focus on doing a Pomodoro, a 25-minute timed work session, not on completing a task. The essential idea here is that the zombie habitual part of your brain likes processes because it can march mindlessly along. It's far easier to enlist a friendly zombie habit to help with a process than to help with a product. By focusing on process rather than product, you allow yourself to back away from judging yourself. Am I getting closer to finishing? And instead you allow yourself to relax into the flow of the work. The key is when a distraction arises, which it inevitably will, you want to train yourself to just let it flow by. Of course, setting yourself up so that distractions are minimal is also a very good idea. Many students find that either a quiet space or noise-canceling headphones, if you can afford them, can be helpful when they're really trying to concentrate. I'm Barbara Oakley. Thanks for learning about learning.
For logistic regression, we previously talked about two types of optimization algorithms. We talked about how to use gradient descent to optimize this cost function j of theta, and we also talked about advanced optimization methods, ones that require that you provide a way to compute the cost function j of theta and that you provide a way to compute the derivatives. In this video, we'll show how you can adapt both of those techniques, both gradient descent and the more advanced optimization techniques, in order to have them work for regularized logistic regression. So here's the idea. We saw earlier that logistic regression can also be prone to overfitting if you fit it with a very sort of high order polynomial features like this, where g is the sigmoid function, and in particular you may end up with a hypothesis, whose decision boundary is this sort of a overly complex, extremely contorted function that really isn't such a great hypothesis for this training set. And more generally, if you have logistic regression with a lot of features, not necessarily polynomial ones, but just with a lot of features, you can end up with overfitting. This was our cost function for logistic regression, and if we want to modify it to use regularization, all we need to do is add to it the following term plus lambda over 2m, sum from j equals 1, and as usual, from 1, sum from j equals 1 rather than sum from j equals 0 of theta j squared, and this has the effect, therefore, of penalizing the parameters theta 1, theta 2, and so on, up to theta n from being too large. And if you do this, then it will have the effect that even though you're fitting a very high order polynomial with a lot of parameters, so long as you apply regularization and keep the parameters small, you're more likely to get a decision boundary that maybe looks more like this and looks more reasonable for separating out the positive and the negative examples. So when using regularization, even when you have a lot of features, the regularization can help take care of the overfitting problem. How do we actually implement this? Well, for the original gradient descent algorithm, this was the update we had. We would repeatedly perform the following update to theta j. This slide looks a lot like the previous one for linear regression, but what I'm going to do is write the update for theta 0 separately. So the first line is my update for theta 0, and the second line is now my update for theta 1 up to theta n, because I'm going to treat theta 0 separately. And in order to modify this algorithm to use the regularized cost function, all I need to do is pretty similar to what we did for linear regression, is actually to just modify this second update rule as follows. And once again, this cosmetically looks identical to what we had for linear regression, but of course is not the same algorithm as we had, because now the hypothesis is defined using this. So this is not the same algorithm as regularized linear regression, because the hypothesis is different. Even though this update that I wrote down, it actually looks cosmetically the same as what we had earlier when working out gradient descent for regularized linear regression. And of course, just to wrap up this discussion, this term here in the square brackets, so this term here, this term is of course the new partial derivative with respect to theta j of the new cost function j of theta, where j of theta here is the cost function we defined on the previous slide that does use regularization. So that's gradient descent for regularized linear regression. Let's talk about how to get regularized linear regression to work using the more advanced optimization methods. And just to remind you, for those methods, what we needed to do was to define a function, that's called the cost function, that takes as input a parameter vector theta. And once again, in the equations we've been writing here, we use 0 index vectors, so we had theta 0 up to theta n, but because octave indexes the vectors starting from 1, theta 0 is written in octave as theta 1, theta 1 is written in octave as theta 2, and so on down to theta n plus 1. And what we needed to do was provide a function called cost function that we would then pass into what we saw earlier. We would use the f min u and c, and then at cost function and so on, right? But the f min u and c was the f min unconstrained, and this was what would, and f min u and c was what would take the cost function and minimize it for us. So the two main things that the cost function needed to return were first jval, and for that we need to write code to compute the cost function j of theta. Now when we're using regularized logistic regression, of course the cost function j of theta changes, and in particular now our cost function needs to include this additional regularization term at the end as well. So when you compute j of theta, be sure to include that term at the end. And then the other thing that this cost function thing needs to provide were the gradients. So gradient 1 needs to be set to the partial derivative of j of theta with respect to theta 0. Gradient 2 needs to be set to that, and so on. And once again, the index is off by 1, right, because of the indexing from 1 that Octave uses. And looking at these terms, this term over here, we actually worked this out on a previous slide. It's actually equal to this. It doesn't change because the derivative for theta 0 doesn't change compared to the version without regularization. And the other terms do change, and in particular, the derivative with respect to theta 1, we worked this out on the previous slide as well, is equal to the original term and then minus lambda over m times theta 1. Just so we make sure we pause this correctly, if we can add parentheses here, right, so the summation doesn't extend. And similarly, this other term here looks like this with this additional term that we had on the previous slide that corresponds to the gradient from the regularization objective. So if you implement this cost function and pass this into f min u and c, or to one of those advanced optimization techniques, that will minimize the new regularized cost function j of theta, and the parameters you get out will be the ones that correspond to logistic regression with regularization. So now you know how to implement regularized logistic regression. When I walk around Silicon Valley, I live here in Silicon Valley, there are a lot of engineers that are frankly making a ton of money for their companies using machine learning algorithms. And I know we've only been studying this stuff for a little while, but if you understand linear regression, logistic regression, the advanced optimization algorithms, and regularization, by now, frankly, you probably know quite a lot more machine learning than many, certainly not all, but you probably know quite a lot more machine learning right now than, frankly, many of the Silicon Valley engineers out there having very successful careers, making tons of money for the companies or building great products using machine learning algorithms. So congratulations, you've actually come a long ways, and you actually know enough to apply this stuff and get to work for many problems. So congratulations for that. But of course, still a lot more that we want to teach you. And in the next set of videos after this, we'll start to talk about a very powerful class of nonlinear classifiers. So whereas linear regression, logistic regression, you can throw in polynomial terms, but it turns out that there are much more powerful nonlinear classifiers that can than sort of polynomial regression. And in the next set of videos after this one, I'll start telling you about them so that you have even more powerful learning algorithms than you have now to apply to different problems.
Traditionally, in computation and processing data, we would bring the data to the computer. You'd run a program and you'd bring the data into the program. In a big data cluster, what Larry Page and Sergey Brin came up with is very simple, is they took the data and they sliced it into pieces and they distributed each, and they replicated each piece or triplicated each piece, and they would send it, the pieces of these files, to thousands of computers. First it was hundreds, but then now it's thousands, now it's tens of thousands. And then they would send the same program to all these computers in the cluster. And each computer would run the program on its little piece of the file and send the results back. The results would then be sorted, and those results would then be redistributed back to another process. The first process is called a map, or a mapper process, and the second one was called a reduce process. Fairly simple concepts, but it turned out that you could do lots and lots of different kinds of, handle lots and lots of different kinds of problems in very, very, very large data sets. So the one thing that's nice about these big data clusters is they scale linearly. You add twice as many servers and you get twice the performance and you can handle twice the amount of data. So this just broke a bottleneck for all the major social media companies. Yahoo then got on board. Yahoo hired someone named Doug Cutting, who had been working on a clone or a copy of the Google Big Data architecture, and that's now called Hadoop. And if you Google Hadoop, you'll see that it's a now very popular term. And there are many, 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 if you look at the big data ecology, there are hundreds, if not thousands, of companies out there that have some kind of footprint in the big data world. Most of the components of data science have been around for many, 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 many decades, but they're all coming together now with some new nuances, I guess. At the bottom of data science, you see probability and statistics. You see algebra, linear algebra, you see programming, and you see databases. They've all been here. But what's happened now is we now have the computational capabilities to apply some new techniques, machine learning, where now we can take really large data sets, and instead of taking a sample and trying to test some hypothesis, we can take really, really large data sets and look for patterns. And so back off one level from hypothesis testing to finding patterns that maybe will generate hypotheses. Now this can bother some very traditional statisticians and gets them really annoyed sometimes that you're supposed to have a hypothesis that is independent of the data, and then you test it. So once some of these machine learning techniques started, were really the only way you could analyze some of these really large social media data sets. So what we've seen is that the combination of traditional traditional areas, computer science, probability, statistics, mathematics, all coming together in this thing that we call decision sciences. Our department at Stern, I'll give a little plug here, we happen to have been very well situated among business schools because we're one of the few business schools that has a real statistics department with real PhD level statisticians in it. We have an operations management department and an information systems department. So we have a wide range of computer scientists to statisticians to operations researchers. And so we were perfectly positioned, as a couple of other business schools were, to jump onto this bandwagon and say, okay, this is decision sciences. And Foster Provo, who's in my department, was the first director of the NYU Center for Data Science. 4 years ago, maybe 5 years ago. I mean, this is one of those cases where you can just go to Google and search for data science and see how often it occurred, and you'll see almost nothing, and then just a spike. The same thing you would see with big data about 7 or 8 years ago. So data science is a term I hadn't heard of probably 5 years ago. The first question is, what is it? And I think faculty and everybody's still trying to get their hands around exactly what is business analytics and what is data science. We certainly know the components of it, but it's morphing and changing and growing. I mean, in the last 3 years, deep learning has just been added into the mix. Neural networks have been around for 20 or 30 years. 20 years ago, I would teach neural networks in a class, and you really couldn't do very much with them. And now, some researchers have come up with multi-layer neural networks in Toronto in particular, the University of Toronto. And that technology is now rapidly expanding. It's being used by Google, by Facebook, by lots of companies.
Digital transformation affects business operations, updating existing processes and operations and creating new ones to harness the benefits of new technologies. This digital change integrates digital technology into all areas of an organization, resulting in fundamental changes to how it operates and delivers value to customers. It is an organizational and cultural change driven by data science and especially big data. The availability of vast amounts of data and the competitive advantage that analyzing it brings has triggered digital transformations throughout many industries. Netflix moved from being a postal DVD lending system to one of the world's foremost video streaming providers. The Houston Rockets NBA team used data gathered by overhead cameras to analyze the most productive plays, and Lufthansa analyzed customer data to improve its service. Organizations all around us are changing to their very core. Let's take a look at an example to see how big data can trigger a digital transformation, not just in one organization, but in an entire industry. In 2018, the Houston Rockets, a National Basketball Association, or NBA team, raised their game using big data. The Rockets were one of 4 NBA teams to install a video tracking system which mined raw data from games. They analyzed video tracking data to investigate which plays provided the best opportunities for high scores, and discovered something surprising. Data analysis revealed that the shots that provide the best opportunities for high scores are 2-point dunks from inside the 2-point zone and 3-point shots from outside the 3-point line, not long-range 2-point shots from inside it. This discovery entirely changed the way the team approached each game, increasing the number of 3-point shots attempted. In the 2017-18 season, the Rockets made more 3-point shots than any other team in NBA history, and this was a major reason they won more games than any of their rivals. In basketball, big data changed the way teams try to win, transforming the approach to the game. Digital transformation is not simply duplicating existing processes in digital form. The in-depth analysis of how the business operates helps organizations discover how to improve their processes and operations, and harness the benefits of integrating data science into their workflows. Most organizations realize that digital transformation will require fundamental changes to their approach towards data, employees, and customers, and it will affect the organizational culture. Digital transformation impacts every aspect of the organization, so it is handled by decision makers at the very top levels to ensure success. The support of the Chief Executive Officer is crucial to the digital transformation process, as is the support of the Chief Information Officer and the emerging role of Chief Data Officer. But they also require support from the executives who control budgets, personnel decisions, and day-to-day priorities. This is a whole organization process. Everyone must support it for it to succeed. There is no doubt dealing with all the issues that arise in this effort requires a new mindset, but digital transformation is the way to succeed now and in the future.
I'm Norman White. I'm a clinical faculty member in the IOMS department, Information Operations and Management Science department here at Stern. I've been here for a long time, since I got out of college pretty much. I'm sort of a techie, geeky kind of person. I really like to play with technology in my spare time. I'm currently faculty director of the Stern Center for Research Computing, in which we have a private cloud that runs lots of different kinds of systems. Many of our faculty or PhD students who need specialized hardware and software will come to us. We'll spin up a machine for them, configure it, help them and advise on them. And a lot of the data scientists, or virtually all the data scientists at Stern, use our facilities. And their PhD students use them a lot. I have an undergraduate degree in applied physics, and while I was an undergrad, I took a number of economics courses, so I ended up deciding to go to business school, but I had, this was in the early days of computers, and I had gotten interested in computers, and I came to Stern, which was then NYU Business School downtown, and they had a little computer center, and I decided that I was going to learn two things while I was there. One, I was going to learn how to program. I'd taken one programming course in college, and I was going to learn how to touch type. I never did learn how to touch type. Oh, maybe I did, but I forgot. Now I'm back to two-finger pecking. But I became a self-taught programmer, and then I took a number of courses at IBM, because I eventually became the director of the computer center while I was getting my PhD in economics and statistics at Stern. So in 1973, the school formed a department called Computer Applications and Information Systems, and I was one of the first faculty members in the department, and I've been here ever since. So my typical Monday is I usually get in around 11 o'clock, and I do my email at home first, but I come in and I have two classes on Monday. I have a class on design and development of web-based systems at 6 o'clock. 2 o'clock I have a dealing with data class. The class is based all on Python notebooks. So we start with sort of the basics of Unix and Linux, just to get the students used to that. We move on to some Python, some regular expressions, a lot of relational databases, some Python pandas, which is sort of like R for Python, but you do mathematical and statistical calculations in Python. And then I end up with big data, for which, as you probably know, I'm an evangelist. And the students have weekly homeworks. I put them in teams, and they have to do a big project at the end of the term. And they do some really cool things. Yes, in fact, the whole course is taught using Jupyter Notebooks. Every student has their own virtual machine on Amazon Web Services. So we pre-configure all the machines and they get a standard image that has all of the materials for the course either loaded on it or in a Jupyter Notebook there are the commands to download it or update the server with the right software. So everybody's in the same environment. It doesn't matter what kind of, whether they have a Mac or a Windows machine or how old it is. Everybody can do everything in the class.
crack. Provide. Reach. Desire.
Clip hôm nay tôi sẽ nói về chuyện 15 chú chó bị thiêu hủy ở Cà Mau.
Kêu nó chị đi bỏ chủ đi, không chịu. Nó không chịu đi, đến nào mà nó rơi nước mắt kìa.
Đây là một cái câu chuyện làm cho cộng đồng mạng rúng động. Rất nhiều người yêu thương động vật, những người đang nuôi chó nuôi mèo, người ta nổi giận. Đó là chuyện đương nhiên rồi. Mà người không nuôi chó không nuôi mèo, chỉ cần là con người có lòng trắc ẩn là người ta cũng cảm thấy không thể nào mà chấp nhận được một cái quyết định dã man tới mức như vậy. Các bạn thử tưởng tượng coi, hai cụ ông cụ bà trải qua một cái quá trình hành trình từ đây về tới Cà Mau khổ khăn không biết bao nhiêu, mà người ta còn đem 15 con chó về tới nơi được, để rồi tận mắt thấy tụi nó bị tiêu hủy, bị giết vì nhân danh chống dịch. Tôi nói thiệt với mấy bạn, tôi nghe cái tin này xong tôi cảm thấy nó vô cùng mà phẫn nộ. Thực ra nhiều người phẫn nộ tôi hiểu lý do vì sao, nhưng mà các bạn biết không, tôi làm cái clip này mục đích chính là để giúp cho các bạn hiểu được đây không chỉ đơn thuần là một vấn đề của hành động vô nhân đạo hay không, mà nó là một vấn đề xã hội và tâm lý. Nếu chúng ta không hiểu rõ vì sao lại có những cái quyết định dã man như vậy, và chúng ta không làm gì để ngăn lại những cái quyết định đó, thì chuyện này sẽ còn xảy ra nữa, và một ngày nào đó John Wick sẽ về Cà Mau thôi.
I'm thinking I'm back.
Cho nên coi clip rồi sẽ hiểu. Vụ 15 chú chó bị thiêu hủy ở Cà Mau này, chúng ta giận, chúng ta tức. Nhưng thực sự nếu các bạn để ý cho kỹ thì đây không phải là vụ đầu tiên. Các bạn có còn nhớ về vụ bé mèo bị chặn lại không được đưa đi bác sĩ thú y hay không?
Trời, con mèo đi đâu?
Đi khám rồi, nó yếu rồi chú ơi.
Con mèo nó yếu lắm mà hả? Bây giờ con mèo nó có quan trọng bằng dịch bệnh bây giờ không?
Đúng vậy, nó là một trong những kết quả của hành trình chống dịch trong 2 năm vừa qua của đất nước chúng ta. Hôm nay tôi sẽ giải thích cho các bạn biết lý do vì sao lại có những chuyện như vậy. Những hành động mà người có sự cảm thông, người có nhân tính, chúng ta sẽ cảm thấy đau đớn đến như vậy. Đầu tiên, đó là vấn đề về chuyên môn. Các bạn chỉ cần Google một chút xíu, hoặc các bạn là bác sĩ thì các bạn cũng có thể lắng nghe những bác sĩ như là bác sĩ Hữu Khánh Trương ở trên Facebook. Chúng ta đều biết là cái chuyện mà truyền virus corona từ chó sang người là không có. CDC của Mỹ đã nói, bác sĩ cũng nói, và ngay cả những bác sĩ đã từng tham gia chống dịch đưa những người bệnh đi cách ly và nuôi chó của người bệnh, họ cũng đã xác nhận chuyện này. Cái quyết định của những người ở Cà Mau đem tiêu hủy đàn chó 15 con này để nói rằng là
lỡ nó bị dương tính rồi nó lây cho người gì,
mà chỉ cần một cái Google thôi. Nhưng cuối cùng đàn chó vẫn bị thiêu hủy. Đây là một quyết định của sự thiếu chuyên môn. Dĩ nhiên á, đối với những người mà không có nuôi chó, những người coi chó chỉ là đồ ăn, hoặc là coi chó chỉ là một cái con vật gì đó và có thể nói được những câu giỡn đùa kiểu như
chó là bạn không phải tao,
giống như cái câu từ tiếng Anh chó is friend đại loại, thì những người đó họ chắc chưa bao giờ nghe nói tới một cái gọi là therapy dog. Tức là chó ở nước ngoài, ở những nước phát triển, người ta phát hiện ra là nó không phải chỉ là một thú nuôi đơn thuần, mà các loại thú nuôi không phải chỉ có chó, tụi nó có tác dụng giúp tâm thần, tinh thần của những người trở nên yên ổn hơn. Đặc biệt là những người già, những người mà thiếu đi con cái, những người sống cô đơn, những người đó rất cần sự hỗ trợ tinh thần đến từ những con vật nuôi như là chó, mèo. Thiếu đi những cái con đó, nó sẽ giống như là sự chia tay, giống như là mất đi một đứa con, một người thân trong gia đình vậy. Những người mà nuôi chó chúng ta có thể hiểu được điều đó một cách dễ dàng. Những người có trái tim nhân hậu, người ta cũng hiểu được điều đó một cách dễ dàng. Chỉ có những đứa ác độc, tụi nó mới có thể cười cợt trên cái nỗi đau của đồng loại như vậy thôi. Nó không hiểu được cái vị thế của những con thú nuôi như là những viên thuốc tinh thần. Đó cũng là một vấn đề nằm ở sự thiếu chuyên môn. Vấn đề thứ hai, chúng ta hãy xem xét thí nghiệm Milgram, The Milgram Experiment.
Ủa anh Leo, trời đất ơi, chuyện này xảy ra ở Cà Mau có liên quan gì tới nước ngoài đâu, tự nhiên xem xét một cái thí nghiệm sặc mùi tiếng Anh vậy anh nhân cơ hội này đến khoe khoang phải không anh?
Không mấy bạn, đây là một thí nghiệm tâm lý tôi đã có trong cái clip Vì sao xã hội vô cảm, mọi người coi cái đó đi, nhưng mà tôi sẽ nói lại một lần nữa trong này. Thí nghiệm Milgram nó rất là đơn giản. Đây là một thí nghiệm được coi là một trong những cái thí nghiệm mà tàn khốc vô nhân đạo nhất, mặc dù từ đầu tới cuối không hề có máu me, không có ai bị gì hết, bởi vì cái kết quả của nó nó ra cho chúng ta thấy được cái mặt tối trong con người của chúng ta. Vậy thí nghiệm nó như thế nào? Nó là như vậy. Ông Milgram ổng mướn 40 người để tới làm thầy giáo. Ổng đứng kế một thằng là thầy giáo trong một căn phòng kính, đối diện là một tấm kính, và trong phòng đối diện là có một đứa cũng người của ông Milgram đóng giả là học sinh. Học sinh ngồi đó sẽ trả lời những câu hỏi. Nếu mà trả lời sai á, thì ổng kêu cái thằng mà giáo viên, là cái thằng mà tham gia một trong 40 đứa, mày chích điện nó cho tao. Thì những người này được quyền chích điện từ mấy chục volt cho lên 400V. Mà các bạn biết điện của chúng ta là 220V. 400V là nó gấp đôi rồi, đau đớn kinh khủng lắm. Thì ban đầu 40 người này đều
Thôi kỳ lắm, trời ơi, tự nhiên làm người ta đau khổ, đau đớn em làm không được đâu anh ơi.
Nhưng các bạn biết không, cho tới kết thúc thí nghiệm á, chỉ có 14 người bỏ cuộc mà thôi. Mà bỏ cuộc là sau khi mà họ đã qua tới ngưỡng mà 100 mấy V nọ mới bỏ cuộc. Còn 26 người còn lại đi tới cuối cùng thí nghiệm. Nghĩa là mặc dù cái người ở bên kia bị điện giật có đau đớn kêu khóc cỡ nào đi nữa, họ cũng vẫn vặn lên tới 400V chỉ vì có ông giáo sư đứng kế bên.
Không sao đâu, tôi nói anh cứ làm đi.
Và thí nghiệm này sau khi được lặp lại nhiều lần, người ta cũng có kết quả cũng gần tương tự như vậy. Tỷ lệ luôn là hơn 60%. Mặc dù ai mới vô cũng nói
Tôi sẽ không bao giờ làm hại ai hết, tôi không làm được chuyện đó đâu.
Nhưng khi kết thúc thí nghiệm thì hơn 60% người luôn đi đến cuối cùng, sẵn sàng làm hại đồng loại của mình chỉ khi có người kế bên nói không sao, cứ làm đi. Đó là một cái bằng chứng cho chúng ta thấy dưới sự lãnh đạo, dưới quyền lực nghe lệnh của một ai đó, chúng ta sẽ làm được những điều vô cùng mất nhân tính. Chúng ta sẽ làm được tất cả. Thì chuyện này á, nó đã từng được chứng minh ở trong những cái tòa án như xét xử những tên Đức Quốc xã ở thời mà Thế chiến thứ hai rồi. Nhưng cái này các bạn nếu mà không rõ ràng, các bạn có thể nhìn vào một nhân vật vô cùng đơn giản, đó chính là chú bảo vệ hoặc là ông giữ cổng. Các bạn có để ý không, những người đó luôn có thái độ hách dịch, người ta luôn làm những cái chuyện khó khăn cho mình. Nhưng tại sao người ta lại làm như vậy? Bình thường người ta cũng đàng hoàng lắm, nhưng khi dính vô cái mặc cái đồng phục lên, cái bắt đầu tự nhiên ta biến thành con người khác. Đó là bởi vì khi người ta làm dưới cái chỉ đạo của một người khác thì họ sẽ làm mọi thứ, bởi vì cuối cùng họ nói
Không, cái này không phải lỗi do tôi, cái này là do cấp trên biểu thôi.